I'd like to zoom into one of the components in one of the stages in our continuous delivery of actually continuous integration pipeline, the testing stage, and then to be specific, the performance testing. I hope you appreciate my shiny new slide deck. I got some feedback the last time I gave the talk. I used Google Slides, and they say, "Oh, they're boring." And so, well, you can say a lot of things about my slides now, but they're not boring anymore.
We will judge.
Maybe the contents, but the looks are. No, I've created a little agenda for this talk. I'll introduce myself. Then I tell you a little bit about the transformation within KLM from a project-oriented organization to an agile organization. I'll tell you a little bit about how we implemented continuous performance testing, what tooling we used, and if the demo gods are with me, I can also show you some live action. To start with me, my name is Daniel, as I just said. I've been working in performance testing for almost 14 years now. I actually started my performance testing career over here at ING in 2003, a long time ago. Since 2005 I work as a freelance contractor for 11 years now, and of which 8 years I've been at KLM, which is a long time. And the last few years my work changed dramatically. Since I started focusing on integrating performance testing in continuous integration. As for you, I saw there were lots of engineers here. How many of you actually have been involved in performance testing? Okay, well, that's nice. So I'll just assume for now, because this is not going to be a talk about performance testing for dummies, so I assume you know what performance testing is about. And if you have any questions, just raise your hands and I'll try to answer them for you. Like so many companies nowadays, KLM decided to make the shift from a project-oriented based organization to an agile organization, and this. I think this program started around 2 to 3 years ago, trying to initiate this change. I was, as a senior performance tester, was contacted by the program to start thinking with them how to incorporate performance testing in this change. KLM has a long tradition of performance testing their applications. And with good reason. For instance, the booking tool, if it goes down for 1 hour, there's a loss in revenue of about 3 million euros. It goes real fast. Also, for instance, a check-in application where you do your internet check-in. If it breaks down, the queues will pile up at the airport, and these are also very costly incidents. So it's been since long, all applications are thoroughly performance tested before go live. The existing organization by that time was applications were released about 2 or 3 times per year and developed according to waterfall development. Performance tests were executed just before go live. Actually, most of the time it was the last hurdle before go live, so I always had to deal with stressed out project managers who only saw the test as a hurdle and just wanted to go live. So the performance test result is one of the most important inputs for operate permit, which is actually a formal handover from development to operations. And by that time, throughput time for performance tests were around 2 to 3 weeks, which included a preparation phase, execution phase, analysis, and a reporting phase. And all tests were executed by a specialist team of performance testers. By the time we had 6 load runner specialists serving around 30 projects and in total doing around 100 go lives per year. The target organization looked a bit like this. Of course, agile development with the main goal, shorter time to market, but also do this without compromising quality. That means in terms of performance, we still had the same performance requirements, and we still had needed the same test coverage as before. We had 2-week sprints and monthly releases. Instead of having 3, we had 12 per product. And one of the other main goals was to have autonomous teams. And autonomous meaning in this context, no dependencies on other teams to make the sprint planning. So you don't want to have any allocation issues for planning your sprint. So you want to do everything yourself, be in control. Truly autonomous means, of course, that you decide yourself that you go live as well. But at that time, it was decided not to grant those rights yet to the teams, and first let them prove their level of maturity. So, and actually, for lots of teams, we are still in this stage as we speak. As I said, zip. As you can imagine, there was lots of challenges going from the existing situation to the target situation. For instance, the throughput time of the performance tests. If you have 3 weeks of throughput time for a test, then you have 2-week sprints. That leaves hardly any time or no time to actually develop your features. Also, defects just found just before go live will result in a no-go. Well, this was actually the same as before. But now time to market is even more important, so missing your go live has more impact. And due to the complexity of the test, the throughput time of the tests, there was an enormous scarcity in performance test resources like test environments and testers themselves. So there was lots of dependencies in planning. For instance, if you, as a project, want to plan a go live, you had to, in advance, 6 months in advance, you had to allocate resources to do your load testing. So this is something you can imagine if you're trying to increase the number of go lives by a factor of 4 or more. This is going to be an issue for sure. So it's therefore no surprise that performance testing was named as the #1 impediment by agile teams in a survey in preventing them from becoming truly agile teams. But the funny thing is that the solution we found actually was to do even more performance testing than the number of go lives would suggest, because we started to do continuous performance testing. And I'll try to explain to you what that means. This quote actually is from a book we just saw in Daniel's presentation, Continuous Delivery. I once I was in one of the talks by one of the co-authors, Jess Humble, and it was a great presentation. And one of my key takeaways was this one: if it hurts, do it more often. And which basically means if something is really complex, you should do it more often and practice a lot, and then after a while it becomes easy for you to do it. Well, that's what we started to do. Specifically, that's what we wanted the teams to start doing this. So we took the approach of embedding the performance testing in the existing teams. Another approach would be to take specialists and put one of them in each team. This is something I know for at the Rabobank they do it this way. But it also means they have a team of 40 performance testers over there. And this was not at KLM not a solution. Was not scalable for us. So we decided to do it the other way around. And we found also if once once the team masters the skill of creating load test scripts, they could actually do it much more efficient than we could, because they know the application thoroughly and by heart, and they can create the scripts a lot faster than we could. We try to get feedback on performance starting early in the sprint, and preferably every day. So what we do is in our CI pipeline, we have a stage next to the functional quality checking. We also have a non-functional quality checking for performance. A team codes during the day and commits the changes, and in a nightly build, those are performance tested. And when you the next day come in, you have feedback on performance of your last commits instantly. When you start working in this fashion, it means if you start working in this fashion, you also have to maintain your test work constantly, because you might introduce some new feature, then you need to change your load test script, or your load test script might be broken due to one of changes that you didn't see coming. So what you do is, once your build fails for some reason, you have to fix it. So either fix the application or fix your script. And the positive side effect of this is that by the time you actually go live, or are planning to go live, and you have to enter your cycle of acceptance performance testing, there's no preparation phase anymore, because you are already up to date, everything works, your script is just a formality just to run the test. So in this way, we actually managed to get from what I said earlier, the 2 to 3 weeks. Right now we are down to 55 hours only, so it's a huge improvement.
Well, actually, with your sprint taking 2 weeks, you
Yeah.
still have 2 weeks. Because it's still taking 2 weeks. He's just going in parallel.
Yeah, that's true. You're actually doing. It's also a matter of. It's not you're not doing extra work. You're doing it in a different moment.
Okay.
Yeah. The framework we created is also aimed at maximizing feedback for the team on the performance and minimize the effort to do so. So as a team, you don't want to spend every day 1 or 2 hours analyzing load test results or firing up scripts. So what we did is automate everything. That was the main goal.
Daniel?
Yeah.
Those performance scripts,
Yeah.
were they stored together with the code base in the same
Yeah.
repository?
Yes. I'll get to that later when we talk about the choices we made in tooling. But first, I'll tell you a little bit about automation. The easy part was actually executing the tests. So we have here, this is actually a continuous integration pipeline in Bamboo. What you see over here is some stages. So the application is being built and is being deployed in some testing environment. We have some functional regression testing, and if that passes, it's deployed to a acceptance and testing environment, and where the load test is executed. In this case, the load test is failing, and I'll show you in a bit why. Because that was the more difficult part, was actually to automate the analysis of the results. So you don't spend, as a team, too much time on looking into that, but you just look at consolidated results. What you see over here is actually a few nightlies, and the little icons over here just give you a consolidated results over checks that are done on the result metrics. I'll show you in a bit later in the demo what it means, but the ultimate goal of this is to for the team, if all these checks stay in the green, then your build will actually pass in your CI server, and as a team, you know your application lives up to a certain quality that you have set for it. So, and at that time, you don't need to go into you don't even have to look into the results. You just continue developing features. The checks that are done daily are a requirement check. So for any metric you are recording during your test, you can set requirements. The most obvious is, for instance, transaction response time should be within so many seconds. But this could also be CPU usage or whatever. Well, actually, whatever metric you are capturing, you can set a requirement for. We do a benchmark to the previous build, meaning it will make an analysis of the differences between the two builds, and this will provide you feedback on your latest commits. So if some of the benchmarks are flagged red, the only thing you do is you just check your latest commits to find out where your defect is. You don't have to look into weeks of work, you just have one day of work you have to check. And we do a benchmark to a fixed baseline to prevent from metrics just gradually going up. And usually we take a current live version as a baseline for the new sprint. As I mentioned earlier, the old operate permit process is still in place. At KLM we have a certain role, it's called the technical product architect, who is responsible for capacity planning of the shared infrastructure. And they are the people that give the technical go live, they make the technical go live decision based on, among others, the test results from the performance test. These people, they expect us to deliver a report, so not a bunch of raw data in graphs. They want us to report on requirements that are, and they want to have some nice graphs with it, with some annotations. And what we found when applications are in this monthly cycle for a while, the deltas between releases are not that big usually. So if there's no regression, then actually the report was almost identical every time. So instead of creating a report by hand all the time, which took us about half a day, copying, pasting into Word documents and graphs, and then look at it, well, shit, it's the same report as we did last time. So what we did is we automated this as well. So right now, if your application has no regression and the load is similar to as your previous release, the whole report is generated automatically and can go straight to the stakeholder. Now something about the tooling we use. We use Gatling mainly as a load test tool. When I started investigating the possibilities of using what tool to use for load generation, the first thing we did was actually get rid of all the HP tools because they don't integrate with anything.
For the record.
So we decided to go with Gatling. It's quite a new open source tool, very popular at the moment. Of course, number one is still JMeter in open source load test tooling, but I think this one is a lot better. We use Graphite which is an open source metric store, time-based series metric store. We use Jenkins or Bamboo, whatever, some CI server to trigger tests and run the test from a job. We use some Git-based repository to store the scripts. And as you mentioned, nowadays the scripts are just a module of the actual application, and they move along with along the branches and the versions and whatever. it's become a part of the code base actually. Maven we used to actually build the Gatling script, which is just a jar actually. Then we use a custom-made dashboard to graphically display metrics and to do some automated analysis of the figures. Just recently, we also integrated the JMeter in the setup, so you can use that tool as well if you like. And we even integrated load runner, so so load runner doesn't integrate with anything, but we created the integration for load runner. So just to zoom in a bit more on why we chose Gatling. It integrates well with all the development tools. Actually, it's a really developer-oriented tool. The script is all in code, no UI there, not like JMeter or load runner where you need specific UI to create your scripts. You can edit your scripts in per your favorite IDE yourself, and performance test becomes just a part of your code base. It has a nice and clean, flexible DSL that developers pick up easily. Actually, I was the one introducing the first scripts myself to the developers, but soon I got from the developers really fancy scripts that were much more better than the ones I created, with nice modular setup and configuration files. And so what I started doing is was collecting all these features and creating put them in a Maven archetype. So if we have new projects now, they can generate from the archetype, generate a project, and all they have to do is actually put in the application-specific stuff.
The scaffolding.
Yeah, it's like a scaffolding. Yeah.
What is DSL?
Sorry.
What is DSL?
What's the domain-specific language? But it's based on Scala, which scares a lot of people. When Scala, then we'll see a lot of developers go, "Oh, Scala, I don't want to do that." But I mean, I'm not a developer, and I can manage to create scripts. Because it's not really, you're not really programming. It's a scripting language.
So you can also use Python, or is that an old version of that?
No, I never heard of that.
You can probably do both.
So I created a little picture here to show you how all the components interact. Over here we have a developer or a tester creating scripts locally on the laptop, and once they have tested the script, they push it up to some repository. Then Jenkins or some other CI tool triggers the test, and it will check out the code, build the test, and it will start testing, putting a load on the system on the test. Gatling has a Graphite listener and will actually push all the load-related metrics like response times and throughput to Graphite. And at the same time, we are collecting from the system under test system resource metrics. This could be operating system metrics, but for instance at KLM we have lots of Java applications, so we collect JVM metrics. So then we have all relevant data or metrics in one place, and we use the dashboard to graphically display the data so it's ready for analysis. And like I said earlier, it also has some benchmarking capabilities and some automatic analysis of the results, which it will provide as feedback to the build tool. And the build tool uses this feedback to either pass or fail your build.
If the benchmark is below a certain threshold, the build is failed.
Yeah, those actually the thresholds is up to the team to decide. What we see often is if you set them too strict, then you will have a lot of false positives. So the teams have to learn how to set them correctly. So you don't want false positive, but you don't want to miss any defects as well. So that's. So before I go to the demo part, I want to just wrap up the key benefits for the teams. Using the framework adds performance to your feedback loop, where you would have your functional feedback. Now we have also feedback on performance. It maximizes feedback, minimizes effort, like I said, by automating all tasks that will have to be done quite often if you do run it on a daily basis. It provides teams with at least some form of autonomy in performance testing. But at KLM, at least, there's no more dependencies on our team. A nasty side effect of that is that there's only 2 of us left now in the team. All the others are gone. No, but the good thing is I've spent the last 2 days actually with some colleagues came over from Air France, and they are planning to do similar stuff there, and they want to interview teams about it. So I spent 2 days listening to teams, and one of the best things I heard was that the teams actually said they started coding differently because they are getting feedback on performance instantly. So they also see what their changes are doing when it's running under load. Before, this was a whole different domain. The domain of the application under load was at operations. So they just the application lived in the IDE and locally, and after that it was operations. And now they see what their choices do to performance, and they are much more aware of it. So I think that was really nice to hear. Oh, and last but not least, it's based completely on open source components. Whereas, for instance, Load Runner, we have it again, is extremely expensive. It still is actually. It's become more cheap, but it's still really expensive. Okay. Let me check the time. How long did I spend?
30 minutes, so you still got time.
Okay. Yeah, we can do some questions now if you want, or we can do it after the demo. It's up to you.
It's up to the audience.
Demo? We could also do it during the demo, because of course it's not really exciting to see a test run proceed, but actually this, if you go to my GitHub page.
Can you zoom in a bit?
Sorry?
Can you zoom in a bit?
Let's try. This demo environment is available at the GitHub page. It's actually a through a Docker Compose file, which you can fire up, which will create a number of containers with Jenkins, the dashboard, some testing application, and you can actually run this demo yourself and investigate. What we see here is a Jenkins job, a pipeline job actually. I hope you can read this. What you see here, it checks out some script, and then via Maven execute it. Of course, in a pipeline, this would be preceded by other steps like building your application and deploying it to some environment. But for now, for demo purposes, I just run the script, and in the meanwhile, go over here. This picture I showed you earlier already. What we have here is we have a product and we have a product that has several dashboards. What we normally do for each type of test, we create a separate dashboard. It's easy to organize your test, and you can see also easily browse through different releases over time to see how your test evolved. I can open a test. Now I'll zoom out a bit more. What we have here, we can actually have a graphical. The metrics that are pushed to Graphite, we can analyze visually. I have some load-related metrics over here from Gatling, which are it's a throughput-related, concurrent users. We have some performance, response times, but I also have some in this case some Node.js Node.js resource metrics being pushed from the application into Graphite as well. By now I would expect that this test was running, but it's taking some time. Oh, it is actually running. Okay, so the demo gods are not exactly looking now. Actually, I was planning to run another test. I was planning to run the nightly tests. I have to continue them from here. What you see here is the consolidated results of the benchmarks I was talking about. So what you can do is drill down and see what is exactly being checked. In this case, there's a requirement for response time saying it should be less than 600 milliseconds. And as we can see in this test run, all of those are being met.
Yes, are you checking only the average, or are you checking each result?
And in this we check the average.
Okay.
Yeah.
You probably also have something about the bandwidth, or you could configure that probably.
You can configure. I'll show you. I mean, for every metric you can set a requirement, and you can set some a threshold for the delta you allow.
Yeah. Okay.
So in between tests, and the requirements are pretty straightforward, but the and in this benchmark, the deltas will be checked. It's a shame now I've started the wrong test, but what happens if one of these goes into the red? You, as a team, you drill down into the results and try to find out what the problem is. You can also do some graphical inspections. So sometimes you have some large peak caused by some hiccup that will take that will change your averages. Well, I told you a bit about the reporting part. Like any performance tester, there's not performance testers here, but the part I hate the most is creating reports, because you are spending lots of time copy and pasting graphs and typing the same sentences all over again. So what we do, we actually make this a lot easier. We can put annotations in while analyzing the results, and actually these texts will be saved until the next release, so they will be there automatically as a default text. And if you're finished, you can create a report like this. And
maybe a stupid question, but
yeah.
why don't you give access to the other team to just see these results
Yes.
without creating a report.
Yeah, that's actually what we do now. So
Okay.
yeah, so it's actually the teams themselves that are doing this work. So we've become a service team, as it's called. So we provide support to the teams, and they do all this stuff themselves. And
Yeah, but I was wondering why they have to create a report as a team.
yeah.
Because they have to give it to another department. The other department can simply access this tool. and
Yeah,
see
that's
the
what they do,
results.
but you still
Okay.
It's being generated automatically. It's
Yeah.
being generated automatically, but what the team still needs to do is check that what is being generated is actually true. Because
Okay.
so there's still stuff they have to do manually, but it's not like before. It would take hours and hours, and now it's minutes.
So the next step is automatically mailing to the
Yeah.
department.
Well, actually, the awesome step would be to actually, if you have a continuous delivery pipeline, and these are like nightlies where you're on your develop branch, but you could also have your release branch include all these tests, and then automatically, based on the automated assertions of the results, go to live. Well, I think that's a dot on the horizon, as we say.
And there was one thing I was wondering. You mentioned that you are doing these at the nightly build.
Mm-hmm.
Now, how do you actually square this with? Well, I'm used to the normal practice that every commit gets tested
Yeah.
right away.
Mhm.
So, and of course, there is not much difference in the pipeline you need for the nightly build and the pipeline you need for the
Yeah. Yeah, you could.
for the common build, for the instant build. So,
It's
so
just
how do you get these to work together?
well, technically, it would mean just changing the trigger, and you could also do a test on every commit. But in reality, it's not like we still have a shared environment for load testing. So it's not that every team has a complete life-sized environment for testing. So that's why we don't do it on each commit, but during the night only.
And how do you manage to not do it on each commit and still have the other stages being done on each commit?
Okay, because you have different pipelines actually. You can create
Okay.
pipelines that trigger on commit. You have pipelines that trigger on schedule. You can define any pipeline you want actually.
These pipelines, do they run on shared hardware or on dedicated hardware?
The bamboo, for the nightlies we use bamboo, which is actually shared among Air France and KLM.
Mm-hmm.
So it's on shared hardware there.
Yeah, but for the actual stuff, your performance testing.
Okay, yeah, the test environments are shared as well.
Mhm.
And what we do to make sure we're not testing at the same time is making, in Bamboo you can set specific capabilities for agents, and we have one agent only that is allowed to do the performance testing on a certain environment. That means if some test is running and you trigger another one, it will be queued because it has to wait until that agent is.
Yeah, you
So
can
we
actually-
time slice the environment. That's
Yeah.
basically
You can actually do that in Jenkins as well.
Yeah. We'll do the same. Well, any more questions?
Are these all the performance tests you do?
What you mean? So
Now, I mean, for instance, if you would like to have a endurance test for, say,
yeah.
1 or 2 days.
What I'm showing here is the nightly test, but for each go live, there's a series of tests we do for all applications, which also includes a 48-hour endurance test. We do stress testing. We do slow backend testing, so we simulate providers to be slow or non-responsive, and we do failover testing, so to see if applications are resilient and can handle a failover situation.
Those are automated as well.
Yes.
Okay.
Yeah. But they, indeed. So we can, what we do, we start. We have a multi-job in Jenkins actually.
Mm-hmm.
We start the test, and 55 hours later the report is there. So So that's why we're only 2 left of us now in the team.
That's good.
Okay, well, thanks for your attention.
Oh.